Hi, welcome to my presentation on black holes. So, so let's get started here with just a brief, sort of vague definition of what a black hole is. And a black hole is essentially it's um, a singularity of it's what essentially it is. It's a planet that's been devoured by its own gravity. And what that means is that let's say you have a planet over here and not a planet, well, a star. And um, when that star runs out of fuel, depending on how big it is, it can either explode in a process which called a supernova, or all this fuel, there's no more energy to push to resist that gravity, and this gravity over here basically just devours this star into a tiny little, well, not tiny, but relative to the star's original height, it's very small. And essentially, all this density comes into an infinite, almost infinite state, and that generates a lot of gravity, which basically not even light can escape from it. Okay. So now let's describe parts of a black hole. And some of the the part that you're probably most familiar with is the event horizon. Event horizon. It's kind of hard to write with the mouse. And what the event horizon is also known as the point of no return. And the point of no return is essentially a area around a black hole in which nothing can possibly escape once they cross it. It's the gravitational attraction is so immense that light itself cannot escape from it, which is why you see a black hole as a dark chasm of nothingness, essentially. And the next thing that we have is you can see here the aberration disk. And what the aberration disk is just a bunch of matter that's getting sucked in the singularity or black hole, whichever one you can call it. And let's say this is the black hole and this is the planet. First, the black hole sucks in the planet, and then it tears it up into subatomic particles, which are protons, neutrons, electrons, and they just float here, waiting to be compressed further. The next part we have is the high particle jet streams that goes from here and back over here on the other side. And what these are is just straight particles that have been caught by the black hole and they resist it, which basically forms this tornado-like spiral that's getting sucked into the singularity as well. Okay, so now that you're familiar with the various parts of a black hole, now let's talk about how black hole really has the ability to suck everything in its path, and that can be explained by a very simple concept that as any object in the space-time continuum, the more mass it has, the space-time continuum, you can imagine it as a geometric plane as such, and as a planet, let's say Mars. Let's say Mars is over here. Let me make it a different color. Um, let's say Mars is over here, and this geometric plane, it bends according to the mass of Mars. And this makes sense because if you put something heavy on a trampoline, it's not gonna bend, and that's vaguely the same concept with the space-time continuum. And let's say if this let's call this a trampoline. If this bends, will not attract any of the let's say this is Mars and this is Earth's moon. if this geometric plane bends, will this moon not fall towards Mars? And that makes sense, because if you have a trampoline and you place a heavy rock on it, and then you place a little ball on near the heavy rock, the ball will go towards the rock. It it well, we know that the ball will collide with the rock, but in space, everything is far more astronomical distances and forces. So it might not exactly collide with Mars. It will just orbit around it, which is explained by um, because if an object has enough speed, then it will resist the gravitational forces. And if we apply the trampoline metaphor again, if the ball is spinning quickly enough around the rock, it will not collapse into the rock exactly. And that's how, well, that's a very ambiguous explanation of how it works. So in this picture we have the aspiration disk over here, we have the high particle jet streams over here, and also depicted in this picture is this planet-like figure getting sucked in, the singularity, which is over here. And you can see that all these particles of that make up this figure are being sucked right into the aspiration disk, and some stray particles are coming down to the singularity, which are all concentrated in this one point. So thank you for watching, and I will be explaining further concepts such as how angular momentum affects a black hole, more about the space-time continuum, and the 4 dimensions. So stay tuned and thank you for watching.